right. So just an overview of measurement. I keep talking about, putting numbers to things and data and things like that. What we're really talking about is measurement. And so measurement is where we assign numbers to objects or events, to behaviors, things like that, using rules that will allow us to represent specific attributes as accurately as possible. And so if you've ever taken a scale in one of your psychology classes that you got to score, you saw that maybe some of the items you have to flip the scoring, and maybe you added up some of the questions and that made one subscale and other questions made another subscale. Those are rules, right? Those are all rules that will allow us to end up with numbers that we can assign to represent traits or attitudes or behaviors, probability behaviors, things like that. So that's measurement. And then, an attribute would be, different dimensions that you might have on some characteristic. And one of the things that we have to assume when we're doing measurement is that people vary on whatever attribute we're interested in. If they didn't vary, there'd be no point in measuring it, right? Because we're all the same. So why bother measuring it? So we first and foremost assume that people vary, and that whatever these attributes are, there must be some way to measure them. That might be overly optimistic on some attributes, but we try, right? So we want to have, a way of placing numbers for these characteristics that people vary on. The two major concerns in measurement are reliability and validity. So let's talk about that a little bit. You may have seen reliability and validity in other classes. I know I talk about it in almost all of my classes and in different ways. So this is the way I talk about it for IO psychology. So reliability is the ability of the measure, the scale or the questionnaire or whatever, the observational technique, whatever it is, to produce consistent results. So reliability is whether that score is reliable for an individual. One way to establish reliability, the most common way, is what we call test-retest reliability. So we ask you to take the test, some amount of time passes, and we ask you to take it again, and we look to see whether you got the same score both times. Okay, classic reliability. Okay, but there's other kinds of reliability. So there's what we call parallel forms. Sometimes we want to be able to administer the same basic test twice, but if I gave you the exact same test, let's say before you start some treatment or training, and then like an hour later, I give you the same test, it's like, well, you're probably just going to remember exactly what your answers were, not even expressing your attitude. You're just remembering your answers from the first time. And so maybe I'd like to have two different forms of the exact same test. And so we want to make sure that these parallel forms are reliable. And so the way we can test that is to either in one sitting have a test group take those items like mixed, interleaved with each other, and then after they've taken the test, pull them apart into what will be the two forms and make sure that they got the same score on both forms. The other way to do it is to administer one form and then wait enough time that you think that they're not going to remember the questions, and then have them take the other form and see if you get the same basic score again. So there's different ways to go about it, but the idea is you're trying to end up with the same basic test, but they're different forms. Now, what if you're doing an observation? A lot of times when we do observations, we will have more than one person watching. Maybe we videotaped. Maybe we had those hidden cameras that I talked about in the last section. And so we now have the freedom to watch it on a screen, right? It's really wise to have more than one person watch those videos, because one of the things that we can do is establish whether the behavior is a solid example of what we're looking for, or is it something ambiguous that's not really clear? We're not really sure. And one of the ways that we can find out if that's the case is if we have more than one person watching it. And if one, let's say, says, oh, that was an example of aggression, and the other one said, no, I saw that as neutral, we know that's an ambiguous behavior and we should just discard it. Like, it's not clearly aggression or neutral, it's something and we don't know what it is. So let's just toss it out, not include it in our measurement, right? So inter-rater reliability is talking about how much the raters, the people who are watching the behaviors and deciding what they are, agree. I personally, if I'm going to have observers, I always go for odd numbers. And so I had a study where we were measuring the lengths of the second digit versus the fourth digit. So we took pictures of people's hands and then measured their fingers. And I had 3 observers measure the fingers, and then I averaged across them to make sure that, we were getting a good, like, reliable measurement on these fingers. It's actually harder than you would think to measure fingers. So I thought that was a good way to establish the reliability and make sure that we were all seeing it the same way. The last kind of reliability is really a measure of the items within a scale. And so with internal consistency, we make sure that every item on the scale is correlating with the total score on the scale, at least 0.7 Pearson's correlation coefficient. So 0.7, if you remember your stats or if you've had stats yet, 0.7 is a very high value for a Pearson's correlation. In most psychological research, we're happy if we get a 0.3, we think that's a pretty good correlation coefficient. So this is a pretty stringent requirement that they correlated at least 0.7 or greater. But what we're trying to make sure is that every item within the scale is equally contributing to the total score on the scale. There's a statistic that you can compute called Cronbach's alpha that does this series of correlations between each item and the total score, and then gives you an overall correlation coefficient for all of it. And it's kind of neat on the computer because now you can say, tell me the intercorrelations for each item, so that if you can discover if there's like maybe one item that's pulling the Cronbach's alpha overall down below 0.7, and then you can run your study just taking that one item out. So that's kind of cool. But the point is, we want our scales to be reliable within themselves, right? Like all the items should be feeding into that construct. All right, speaking of constructs, how about construct validity? This is the ability of the measure to assess what it claims to assess. So whatever you're using to measure the behavior or the attitude or whatever, it's really measuring what it's claiming to measure is what we're talking about here. So there's content validity, and that's the idea that the test, or whatever your scale is or whatever, is representing the domain of content that could be included in this scale. So, for example, let's go back to self-esteem again. So if you're going to develop a self-esteem scale, you would want to make sure that the items that are on that self-esteem scale all relate to self-esteem. Seems obvious, but content validity is a way of, like, concretely with a statistical analysis revealing whether all of these items are actually coming from the same pool. So construct validity it should be tapping into one construct. All the content on the scale should be tapping into this one construct. Now, there's another category of construct validity, which is what we call criterion-related construct validity. There's 2 different ways that you can go about criterion-related construct validity. The first one is what we call predictive. And this is where we give you a test today and then see whether it predicts something down the line, something in the future. An example that you might be familiar with is SATs. The premise of the SAT was that you would be able to take that and it would predict your scores and your grades in your first year of college. That there should be a good, strong correlation between how you performed on the SAT and then how you did in the first year of college. It turns out that because colleges are selective based on the SAT, you end up with a narrow range of SAT scores in any freshman class. And so you end up with absolutely no predictive ability because everybody's SAT scores are so similar. They can't, but their grades are not necessarily similar. And so it doesn't predict very well. But that was the premise, is that we would have a test that would predict an outcome. Anybody who's a psychology major may have had the thought, why don't we have some kind of predictive test that lets us know who's going to become a sociopath? That would be beautiful. So far, that has not been developed. But what we're asking is, can we give you something today that will give us insight into what will be coming down the road, things that may happen later. So that's predictive. And then concurrent validity is concurrent criterion related construct validity is where you give two tests at the same time, concurrently, two different tests, and you want to see whether one test predicts your score on the other test that you're administering right now. A lot of times in research, we'll use concurrent validity to see whether a new test that we're developing produces the same outcome as an existing test that we're maybe wanting to supplant. Maybe we want to get people to use our test instead of this other one that maybe is older or has language that's going out of style or something like that. And so we give both tests, and we want to get what's called convergent validity. You might see that word on my little chart there, right? Convergent validity is when you give two tests that are tapping into the same basic construct, they should produce similar scores. If, on the other hand, you are administering two tests that are like oppositional to each other, a person who's high on this test probably should be low on this one. That's called divergent construct validity. And so we might administer, let's say, a SAT score, and then maybe we want to concurrently administer, let's see, what would be something to be like antagonistic to SAT, would be the opposite of SAT. SAT is so broad. Maybe I should say self-esteem. Let's put self-esteem over here. And then something that is maybe a depression score. Maybe we have over here the Beck Depression Inventory. And so we might find that people who are higher on self-esteem, we should show discrimination, that we actually are testing two different things, because your score on the depression scale is either low when you're high on self-esteem, or maybe it's unrelated to your self-esteem score. That would be divergent, discriminant, where we are expecting these two scales to produce different scores. Convergent is we would expect them to produce the same score. So a lot of times when we're developing tests, we do these kinds of criterion-related measures to make sure that our tests are testing what we're expecting them to be testing. I think I should say test again. Test, 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 test. All right. Research ethics. Talking to myself in my office all day is not the best for my mental health, because I'm starting to lose it, aren't I? Test, test. The ethical principles of psychologists and the code of conduct of the APA. Okay, so the idea here in research ethics is that the American Psychological Association has laid out some basic principles that researchers are always supposed to follow. One of the things that can be very tricky as an IO psychologist is that you go off into the workplace and the employer who has hired you doesn't realize there's a step that I need to follow before I start this research. I need to go through the human subjects review. And that is number one on our list of research ethics. You need to make sure that an unrelated body of people look at your proposed study to make sure that you're not potentially harming anyone. A lot of times the employer is thinking it doesn't matter, I'm giving you permission, whatever, but that's the ethical guidelines of the APA, which governs IO psychologists, is that you should always put any study that is going to include any human subjects through the institutional review board so that they can give you feedback about anything that might be potentially harmful. A lot of times when we're the ones conducting the research, we don't see the glaring error that could be harmful to our participants. And so it's helpful to have somebody else to look at what we're planning to do. Now, part of our promise and part of what the IRB will be looking for is an informed consent. We need to tell our participants what basically is going to be happening in the study. You don't have to tell them every single detail if that would disclose your hypothesis. So I don't want to act too rigid about this. But you do tell them as much as they need to know so that they can make an informed decision about whether they want to participate or not. Their ability to decline if they want. Again, the employer sometimes feels like they can't decline. They're here, I pay them, they have to do it. If we're doing research, and I might report this at a conference or publish the results or something, we need to do this ethically, and your employees need to have the right to decline. You can do stuff to try and make it really hard to decline by, offering them pay or offering them time off or things like that make it really hard for them to decline. But you can't make it seem like they have to do it. You have to provide to them any kinds of risks that might come from participating. You also have to disclose any benefits that are coming so that they know what they're getting. You have to give them the opportunity to ask any questions that they have of the researcher. You can't just give them this piece of paper and then tell them to show up. They have to have the opportunity to ask their questions to the researcher. You have to take steps to maintain the confidentiality of the participant data. APA has guidelines where you have to maintain all raw data for at least 3 years. You can convert it into digital data and keep it even longer, but you can keep your raw data indefinitely. You can keep it as long as you want, but it has to be kept for at least 3 years for sure. And you have to keep it confidential, and you have to tell the IRB how you're going to do that. It's going to be on a computer that is password protected, or the raw data is in a locked cabinet in a locked office, or whatever the steps are going to be to maintain confidentiality, so that especially if the participants identifying information is contained in that data. So one of the simplest things that you could do to maintain confidentiality is separate the names from the data. That's like research 101. Make sure that the data doesn't have names on it. That's really an easy thing to do, but you want to make sure that even if somebody broke into your office and hacked into your computer and found your data, there's no way they'd be able to figure out who said what in your study, including the employer. Avoid the use of deception as much as possible. I mean, there are times when we can't tell them the full protocol. We can't reveal everything. But in general, we want to be able to provide to them as much detail as we possibly can so that they feel good about their participation. We want them to leave knowing that we didn't trick them, we weren't trying to make them look foolish or anything like that. We want them to feel good about their participation. And then finally, if there were to be any animals involved, you're working at a veterinarian hospital or something like that, there's an extra step where you have to propose any animal treatment to the animal review board, and they would give feedback about that. That seems really unlikely, but you'd be surprised which kinds of organizations hire IO psychologists. So you might be working for the rodeo convention or whatever, and you might come in contact with animals. All right, this is a good time to take a break, and we will wrap up this chapter with a little statistics. Just a little statistics, no math.